Oh, how's your Friday going so far? It's a Friday, right? Yeah. So last night we had a little welcome at my house for computer students. Some of you were there, which is really nice. Had fun. Played a little cornhole. We're throwing bean bags and doing a lot of focusing. There, a lot of focus. That was the key. Last night's game. But so it was nice to see you, those of you who could make it there. That was fun. Um, just a quick note on the announcements. Um, Besides teaching this course, I also coordinate our internship program. And one thing that's kind of unique about our major, the computer major here, is you're required to do an internship. So all the students on campus can do an internship. Everyone can do an internship. You have to do an internship. No can about it there. So you're required to do an internship as part of the computer major. Now, if you're not a computer major, you don't have to do an internship. I encourage you to do an internship for it. Now, there are some alternatives here, like if you do a summer research project or something like that, that's not actually an internship. We do count that, and there are other similar programs that you can do. But most students do an internship, and often during the summer, a lot of companies have summer internships programs, and they often pay pretty well for that. We do have students who work during the school year, and we'll see some of those posted. But why am I talking about this now? Because this is the start of the recruiting season for next summer's internships. And so you probably are, too early in your career to be looking for an internship in the summer, but sometimes we have first and second year students get internships here. So it's more challenging for first year students, but certainly second year students, the most typical thing is third year students will do an internship between their third year and their fourth year for that. And so we have a couple companies will come on campus and do recruiting events. And so DigiKey is coming next week on Tuesday. Their flyers are kind of up over here and over there. So they'll be coming in here. So they'll be here on Tuesday from 11:45 to 1. So basically over lunch, they'll be down in Tower Hall. They generally buy pizza and try to, again, they're trying to recruit you, so they'll have some free things to give away, and they'll have free pizza and stuff like that. And then they'll spend half an hour, 45 minutes talking about DigiKey and why you should work their company for that. I will share this stuff to our website, and you probably will get emails periodically with this same sort of stuff. There's also a career fair called STEM Fest. It's held at UMD, but it is co-sponsored generally by St. Scholastica too. And so there's one in the fall here. There'll be another STEM Fest in the spring for that. And then actually the following week will be a business career fair, and we'll talk more about that the following week. So again, probably kind of early for you to be doing career fairs, but not depending on where you're at and that sort of stuff. And again, some of you are second year students looking to do an internship. This is a good time to start working that. So we work a lot with career services on this. So if when you want to start thinking about getting a resume together and getting organized, career services offers help with all of that. And they're very friendly and helpful people down there. So, okay, questions at all about that? Okay, let's dive in. So today we kind of have a busy day. Well, you have a busy day. I am not so busy. That's good. So we're going to do the learning activity, and then we're going to work through the assignment. Now, generally, we would have you kind of work on the assignment outside of class. I mean, what are you going to do this weekend? I mean, you're going to be bored, sitting around bored. I wish I had a computer assignment I could be doing on a Friday night rather than sitting here bored. Generally, I'll help provide that for you. But this time, new class, new program and all stuff, and new software, all that stuff, we'll walk through a lot of the assignment for you here. So, but first, let's go up and do the learning activity. So I'm, again, in Brightspace. I'm in content. I'm down here, scrolling down to the learning activity robot algorithm. And it says, we work on here. So what we're going to do is break you up into pairs again today to work on this activity here. And then for the first week, I'm fine with just pairing you up with whoever's sitting next to you there. In the future, we'll be doing more swapping around, but for now, that's just so who's not sitting next to someone. We have a one there, a one there, one there, one there. So you want to pair up here and pair up here again. Everyone else have a pair? It's up to you. It's up. Now, what you'll do is you'll go through this activity and eventually you'll work with your partner on it, but eventually we want you to post your results in the discussion area as part of this stuff. And I want each student to post their own version. So make sure you have a copy of this as you go of what you're working on. So this is just going to have you work through an algorithm, which is a step-by-step process. We're not going to write it in any computer language. We're going to write it in English as best we can. So, and again, we're not too specific to how you write it in the English here. The idea is that you're going to be controlling a little robot here, and you're going to tell the robot how to move, and you can do a couple things. The robot can go north, south, east, or west. So I could tell the robot, go north. There's a wall to the north, and it will just bang into the wall. That wouldn't be very good for the robot there. So besides just saying go north, we can also say check north, south, east, or west. So we can ask the robot to check north there. And if there's a door there, go. Then we could say, oh, check north if there's a door, and if so, then go north. Or check east, and if there's a door there, go east. So you can check if there's a door, and you can go in any direction. And you can also assume you can do basic math, like keep track of a number or a count or something like that for that. I find it helpful. I have this little grid here to help you visualize it. This is the robot here for this. And so you can make a copy of this as you want. So I can say, oh, the robot starts here. I'm going to go down, and then the robot would be here. So the X would be here and not here. And I go down again. And again, just so you're clear, north is up, south is down, west and east for that. And so, yeah, that's the basic idea. And you'll want to do these activities. So read through this and see if you can figure out this first activity. Okay. I'm going to pause this recording. So some people are asking for some clarifications on this. So just so you know, here, what you're trying to do is figure out how many squares there are in the grid. So you might have, like, this one has 9 squares in this room. This one has only 1. And again, this is just another visualization of this. This one has 4 by 4, which is 16. So the question is, how do you tell? So, and what can you do? So you want to write out questions like, well, if I'm going to start here, maybe I want to just go down here and down here. So if I go down, I want to check if I can go down, because maybe I can't. So I'm going to check, maybe check for what did I say? You can check like if there's a door to the south. So check for door south or to the south or something like that? And then if so, go south. Now you can maybe check for a door to the south, another door to the south, and if so, you go south. But what if there isn't? So if not, so if I hit here and I went south, and then there wasn't any more room there, if I had a wall, then I'd have to be in something like this size room where I started, went through one door and I stopped. So then, if I hit a wall, then the room is 4 squares big because it's that size. Again, you want to try to do something. This isn't a very good way of doing it, the way I'm doing it right now, but you want to write out some process where you can check for doors, go through doors, and then tell at various points, well, if this happens, it's only 4 squares, or if it's 16 squares or stuff like that. So that's the algorithm you want to come up with. And again, pseudo, it can be written in English, and we're not too picky about how that is. And again, you're starting in a square room, in the first part, and you're in the upper left-hand corner. And if you get that working, you can go on to the next part where you are starting in a rectangular room, so not all the sides are the same. Okay. So again, if you get done with the square, think about moving on to the rectangle. The simple rectangle, again, you start at the upper left-hand corner, like here, a rectangle. But for the next part, for the activity 3, you start anywhere in the rectangle. So what if you're not at that spot? What if you start at any given location? How do you figure out how big this rectangle is then for this? So keep that in mind. We'll just do this for just about 5 more minutes, and then remember, also, this is a learning activity. We want you to post it to the discussion. If you want to see other solutions, you're wondering, how good is my solution? Is there other ones? You can just jump to the discussion area and say, oh, look like Luke did it. Who's Luke? And so Luke introduces himself. Nice of him. And then he gives you an algorithm here for activity 1. Check if there's a door to the east. If there's a door to the east, move east until hitting wall. Count the moves east. Check if there's a south. Move south until you hit. And then the door size is the east times south here. So now, is he counting the moves or counting the doors? And will this equation work? You can kind of figure that out here. But again, you can look at some of these examples here. And again, we want you to post an introduction to yourself and then this activity. Now, you don't have to do it right in class. You're free to do it in class. But again, sometime before Monday, we want you to post this. Okay? So about 5 more minutes, and then we'll move on.
I'm just doing do the same thing for every single with on the screen it's now you can't reach the endpoint start on the west and reach the southeast, right? Yeah, you take from out and out and that's out. Okay, does that work for you?
Yes, but I mean, what I was thinking is like if the robot check both sides, maybe he take more tools and he just clicks one side because like you just a programmer you already know that 3x3 or square. So I think you can save some steps and you just say okay check this guy. I mean everything people that like everything works anything works.
If you're counting doors, yeah, you can count rooms you're in, or you can count, you can add, it's really. Doors, what you, what all you have, yeah. That's not like the nation of wisdom. Check for the doors, so. If the door go through it, if not, check for the door to the east to go through it. Same thing, every simple way, check doors are. Okay, good. Okay, how do you figure, so here you say if there are no doors to the east on either side of the grid with one by one, what if you do find doors? How do you, so are you counting? Yeah. Well, right, so then how big is the grid then? Based on how many doors you have?
So do the same thing if you take what the rate taking.
Well, or you could just say repeat this, you know,
That goes to the southeast.
right, and you'll end up being very southeast, so if there's no more doors, you know, you can keep going until there's no more doors to the east or the south. And then you counted, well, yeah, so then you counted the number of doors. Right? Going south, you count the number of doors east. How do you what's the basic math formula? If you know how many doors there are going south, how many doors east, how do you figure out the area based on that? Okay, so you just you know, the number of doors, maybe times the number of doors that way, or something like that.
Let's say it's okay.
Why you come like this? Why you just go like this? The whole point is that the robot knows that it's square four. So if you just count 1, 2, 3, or 1, 2, 3, you know, like 1, 2, 3. You know the size.
It's the same, right?
There we
Well,
go.
you go, like you were saying, 1, 2, 3, 4, 5. I mean, I understand, I'm not sure if I'm doing, I think what, like, exercise is to understand the, how many, then you figure here, how do you know about the area?
Yeah, you go down, right? You know it's a square. You go, you know, going down, you know about this area. Because you going down. And if you go east, you know about this, this is concentration. If you go down one, you know about this three. And if you go east, you know
I mean, yeah, I understand, but I think kind of my, because you just go down all the way until it, and down all the way.
what if there are no?
But you already know the programmer, you're seeing this as a programmer, so you already know that there's what it is, you just have to tell the robot how to do it. So if you tell the robot, okay, go south, then go east, go south, then go east, and then go there, like the robot's gonna do it. But I think it's.
The robot might be anywhere in that grid, right?
Make it simple.
Like so that you can say what to do, and you can understand that there's a 4x4 square. Because it's like a formula in math, right? Like you multiply base, so like this, and you go all the area. But if you go.
Right, so.
Southeast. Yeah, like you can express more. Because if you go all the way, like you understand that there's part here, how is the road? But if the road goes here and it hits the wall, you know there's nothing there, so you just go at that point. And if you go here, and it hits the wall, and you already have side, and it hits like down, and then in the bottom, like you don't know, but I don't know.
Okay, so I'm gonna interrupt here. I know you're in the middle of stuff, but I want to move on to the assignment part of this. So again, you can see how far you get. It would be nice to, if I'd hope most of you get you know, at least done through this this first part with the square here and post something that I see a number of people posted the simple square. If you get the rectangle, the simple rectangle and the full rectangle done, that'd be great. Post that algorithm to the discussion area, but each person should do that and post that by Monday. Okay, but we're gonna move on. We're gonna go back here and we're gonna do the assignment and talk about that. So the assignment is going to be writing a little Java. So we've been doing this in English. So now we're going to go back to trying to write in Java and how we do that for us here. So we're going to run NetBeans. So I actually kept NetBeans on my bar down here. So it's actually down here. But if you don't, you can just click on here and start typing in NetBeans. There's NetBeans. And run it that way. Again, we're probably going to use it a lot. So when it's down here in the little bar, you can right click and say, pin it to the bar and it'll stay there. And again, it might open up what you did last class here, and that's what it did here. I'm going to start a new project here. So here's NetBeans. And it's, oops, it is where I left off last class, here. So I'm going to start a new project. So I'm just going to do File, New Project. And again, hopefully you'll remember that we did Java. We always do Java Ant and a Java application. So just leave those as is, assuming they're selected. We want Java Ant and a Java application. So I'm just going to hit next. And now on the second screen, I type in a name. So this is going to be my assignment 1. So I'm going to call it maybe like unit 1 assignment or something like that, or assignment 1, maybe. Assignment 1. And now it has my assignment over here. I'm going to zoom in a little bit more on this code so we can see it. Now, there's a bunch of boilerplate code here, which we'll just leave here. There's these are comments here. This is a package. This is our public class, and this is our public static main. So I'm going to leave all that here, and I'm going to leave these 2 final braces down here. So I'm going to go right here where it says to do code application here, logic here. I'm going to go to the end of that and give myself, hit enter a couple times to have some lines there. Here. So, and then I'm going to try to do a print statement here. So I'm going to go system dot out dot print line, because again, if I look back to the instructions, it said, remember, you can use system.out.println statements to output to the screen. I'm going to go system.out.println here, and I do parentheses, and then I do in quotes, I do some here. So it's my test line. Now it's putting this with a big red line on it. So that means it's not happy. So why isn't this happy? So one thing you're going to want to learn is that if you type something like this, how do you figure out where the errors are for this? So sometimes you'll just recognize it. You look at it, oh, you can just see it, especially when you've done this 100 times. So by November, you'll start recognizing it. But now you probably don't recognize it. So you can just move over it here, and it's sometimes, depending on where you are, it'll say pop up a little thing, semicolon expected here. You can also go to the end, this spot, and say it might suggest some things here, but sometimes those aren't very good. So here I see semicolon expected. So I know, at the end of every line, I always have to have, well, not end of most lines, I have to have semicolon. So I'm going to put a semicolon there. It's still complaining about this system. So then I don't spell very well. So I'm going to say, did I spell that right? So I'm going to go look, how do you spell system wrong? System, S-Y-S-T-E-M. That looks right. So what's wrong? Why is it complaining? I swear I did it just like this here. So why is that wrong?
It is meant to be.
Yes, it's case sensitive. So I have to do capital thing here. So again, another thing is, if I didn't know where that was, I could ask an AI about that. So I could go over to AI and say, why doesn't this Java statement work? And again, almost any AI should help you with this, and it'll help you. So here's the correct way is system. So it says doesn't work because Java is case sensitive. Yeah, we're right on. Man, we're as smart as AI there. And with right capitalization. there. And it also puts in the semicolon. So again, I can look there. So again, the idea is that I need to put a capital here. So, oh, and I at some point erased my semicolon. So now I have that working. I can run this and I'll print out my test line. Now, we don't want you to print out a test line. What do we want you to do? You have two choices. You can print out the lyrics of a song here, or you can print out some ASCII art here. So there's some examples of ASCII art. You can just print out a little bunny or something like that if you want here for this. So again, you can ask if you need suggestions, you know, I can ask ChatGPT. I said, I'm a beginning programmer. Always tell the AI that you're a beginning programmer, otherwise it will write complicated programs that you're not going to understand. Okay, so explain to it that you're just learning. So I need to write a simple Java program to print out the lyrics of a refrain of a popular song. Can you give me a couple examples? And it gives me two examples. This one is kind of weird. I mean, this one just makes sense. Okay, public static, you know, here I already have that class and this. I already have things like that. So I'm not going to change mine. I'm just going to look at the code. So generally, we're not going to necessarily change these lines. We're just going to look at this code here. So there's my code for that stuff. And I could actually copy that, paste it in here, and run it, and it'll print off Twinkle Little Star. But come on, you don't want to do Twinkle Twinkle Little Star, right? That's really a little sad. I can do Twinkle Twinkle Little Star, but you want to do a better song than that. Now this way they did it some other way, and you don't understand that. That's fine. Skip that. There. I wanted to do Bohemian Rhapsody. So I said, give me a famous Queen song. It starts doing Bohemian Rhapsody, and then it kind of, oh, that's copyrighted. I really can't do that for you. So, but maybe another AI, or maybe we could talk an AI into doing that. Or maybe you just know the lyrics to Bohemian Rhapsody, right? We all know that. Song. Okay, so your job is to watch your formatting. We want these to have some we want them all lined up here. Oh, we also put in some comments here, so we can put in some comments. And a comment is a line that starts with a // Here is the refrain. Okay, so try to set up some print statements to print out something creative, and we'll let you work on that a little bit, and then we'll talk about how to submit something like this. Okay. Okay, I'm going to just show you how to submit an assignment. Again, you don't have to submit until Monday here, so you have all weekend to write your. And if you want to write your own lyrics, make up your own song, I would accept that there, because you're just thinking, I want to write my own song there. So that would be just fine here. So again, you do either have some ASCII art here or else you have a song. Now, if you're doing a song, we'd like at least 3 verses of it there. And again, ChatGPT failed me for Bohemian Rhapsody, but just Google comes through. I just say, what's the lyrics to Bohemian Rhapsody? It gives it there, and I can just copy and paste those in here. And set that up. So again, we get this working. So it runs. Again, you either have to you should do the art or the lyrics. You don't have to do them both. If you want to do them both, you can. Okay, but now I've got this done. I'm ready to submit. So I don't know if you've done submissions in Brightspace, but we will be doing that all the time. So we'll go to the assignment here. Oh, and I've got to switch over to student view here. So because I can't submit as an instructor. Okay, so I'm here. I go to my assignment here. I click on that. and I can upload a file here. So I have to go look. It says instructions here. Find your NetBeans folder. So I'm going to open up my file explorer here. Let me just close this. Okay, I'm going to open up my file explorer. I'm going to go to my documents. Inside my documents is NetBeans projects, and there are folders for each project, and I named mine assignment 1. So I'm going to send that to make a compressed folder out of that whole project folder here. So I'm just going to right click on that and say, oops, it used to say send to zip, but we're now on Windows 11, compress to zip file. I want to say compress to zip file. I'll update those instructions on Windows. So compress to zip file, and I'll create this little file here for it. And I want to submit that. So I can just drag and drop that in here if I want. Or if I want, I can say upload, and I can go to documents, NetBeans, and then select that zipped folder and have it there. If you get really stuck, you can just take all the code. For now, if you get stuck, you can just take the code and paste it in this comments. But yeah, that'll work for this week. But in future weeks, we'll need you to learn to do that. So see if you can follow the steps to turn in this zip file here. Find it in documents, NetBeans projects. Find your thing and say compress it. Create this compressed file, and that's the file. Because if you try to submit the whole folder, I don't think that'll work. Yeah, it won't work. So that's why you have to do this compressed stuff. Questions on that? So by Monday, and again, that's why we do this Monday night. So if you get really stuck on this Monday in class, you can say, I did it all, but I couldn't figure out how to do this part of this part. So, okay, but feel free to, if you're done now, that's fine. You can submit it now, or tonight or Saturday. All right. I'm going to stop this.